Now, one basic, simple, but obvious thing that we need is the ability for enemies to detect the player. And so today we're going to cover exactly what you can do to build a system with this sensor that detects when the player is within view. It will detect the distance to the player, and eventually it'll also forget that he saw the player. Okay, so we'll build in a little bit of a search timer so that you can implement this, and it'll help us build out our more advanced enemies in future episodes. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. Okay, so we've got our enemies kind of set up now. They're working quite well. We've got our blackboard, our state machine system, as well as the decision engine. And we've even built a sensor, a regular, just kind of this edge sensor. Let's open an example. This slime enemy has the edge sensor as a child. And the way we built this, it's fairly modular. It's kind of like plug and play, right? You just drop it into the enemy. And then this knows to kind of look for the enemy's blackboard and update that. And so we're going to follow that same pattern as we build a new type of sensor. And the sensor that we're going to build today, the PlayerSensor, is going to be kind of a good template for sensors moving forward. And of course, this is one of the most critical ones for having semi-intelligent enemies. So the goal with this sensor is that when we have our player, let's go to the playground here. When we have our player, and I'm just going to drag this player spawn maybe, if he walks in front of the enemy, we want the enemy to see him and to be able to respond accordingly. And so we might have things like an enemy who's in a normal patrol or walk state, but once he encounters the player, maybe he enters a chase state, or maybe he's got a state like, a ranged attack or something like that. Okay. So this player sensor is going to be critical for that. And I think as we build this player sensor, you're going to get a good feel for how these sensors can work. And hopefully you'll be set up to be able to build your own from this point moving forward if you want to. So I guess we should just talk about those requirements just a little bit more. So it needs to have some sort of area that it can see that represents the vision area, like a vision cone. Okay. So that it knows when the player enters. And then it also would know when the player leaves. Now, on top of that, we might want it to be kind of smart. If the player gets outside of the sensor, how does that affect the enemy's decision making? Does he instantly forget about the player and go back to his patrol? Or is there some kind of grace period where he could be searching for the player? And I think I would like that to be the case where he maybe doesn't forget about the player immediately. But in order for that to feel good, we may even want to add additional context to our Blackboard. And let's go ahead and open that Blackboard script. Okay, currently in our Blackboard script, we have the ability to assign the player as a target and calculate a distance. Okay, so this assigning the player as a target is what we're talking about right now, right? As the player enters or leaves that vision cone, he could become the target and then get removed from that. Now, you may need to have, for your game, if you want let's say you want the enemy to see the player, chase him, and then if the player leaves the vision, he starts searching, then maybe you need an additional variable in here that could be like, searching or something like that. I'm not going to build that. It would be pretty straightforward to implement. And so if that's something you want to do, then that's going to be one of the homework assignments for you. But otherwise, we'll just get the target, which would be the player, and then we'll also calculate the distance. And then that way, this player sensor will not only provide the player as a target if we have him, but it will also provide that distance, which can be used for things like your ranged attack, or even just for a general, melee close attack. It might want to check, am I close enough to be able to attack? Okay. So I think these two values are going to give us a lot of functionality. Okay. So we'll talk about these as we get going. Now, the only thing that you really need if you want to follow along is I do have a few icons in here that are part of the download for this chapter. So we've got this player sensor icon, but this isn't critical. You don't need it for it to work. It's just a nice thing so that it looks pretty in the scene tree. Okay, so if you've got all that stuff and you're ready to go, then let's get started. Okay, so let's begin. I'm going to go ahead and shrink some of these folders, and we just want to make that script. It's going to be pretty straightforward. So I'm going to navigate to my enemies folder. Here it is. And then we've got scripts and sensors. Here we've added the edge sensor. We'll just create a new one, new script, and I'll call this the player sensor. Is that spelled right? Yeah, I think so. Player_sensor. Okay, so let's give it a class name. And we want this new player sensor class to extend area 2D because it's going to need to be able to detect the player. So it makes sense that it be in area 2D. So we'll just update that area 2D, and I'm going to give it that icon as well. So that's down here, my general icons folder. PlayerSensor. Nice. Okay. And then let's go ahead and real quick set up the variables that we're going to need to make this work. I think it would be smart to add a signal. We're not going to use the signal, but it will be there so that it's easy to extend and use later if you need to. So let's make a signal for, let's see, player entered. Is that right? And no, entered. And we'll have another signal for player exited. Okay, so we can emit these. Like I said, we're not going to use them directly because this is going to be smart. It's going to tie into our system, but I think it's just a wise idea. That way, if you have any other node or module within your player or your enemies, you'll be able to hook into these signals without writing additional code, here or in the enemy script. And then in addition to this, I'm going to export a variable that we're going to use to help keep track of that search period that we mentioned. So like if the player leaves the site of the enemy, we don't want him to instantly forget the player, maybe, right? Because he just saw him a moment ago. Maybe we want our enemies to be a little bit more intelligent. So I'm going to just set this variable to be called search duration. And by default, I'm going to make it something like 2 or 3 seconds. I'll just go with 2. I think 3 might be appropriate, but whatever this is the default for your enemies. Since it's an export variable, we can obviously just change it. So not a big deal. And then we need to get a reference to our enemy, right? So that we know who this is attached to. This is going to allow us to access the blackboard so we can update the target and things like that. And then we'll also introduce a timer variable, which is just going to be a float. Okay. And there we go. We could probably call this search timer if we want to, but I'm just going to leave it as is, I think. Okay, so that's the basic script. We're going to use our ready function. We're not going to use process, but we will use the physics process. Okay, so go ahead and change that. There we go. Looking pretty good. I guess one other note. If you do, in fact, let's go ahead and do this. Let's add an additional signal. So if we're using the search, then we might want to have like some signal like started searching, something like that. Okay, I'm going to add that in there. Again, these signals are just probably not going to be too useful today. It's just future-proofing this. Okay, so let's dig into the ready function and let's talk a little bit about how this is going to work. I'm going to go ahead and save this, and I want to take our slime 2, right? This is the guy we've got here, slime 2. Okay, so he's built into our scene. He's got the new enemy state machine with the decision engine and all of that built in. And he's got this edge sensor, okay? And what we're going to do is I'm going to use him as an example. We're not going to hook up a state machine and decision engine that it really incorporates this information today. Instead, what we're going to do is just build the sensor and make sure that it works, because he's using this like kind of basic decision engine that doesn't have a chase state or an attack or anything like that. So he doesn't necessarily need a player sensor, right? So let's just build it and get it in here and get the guts working. So I'm going to go ahead and just add one now that we've created the script, and it's called PlayerSensor. And there we go. So you can see the little icon I've assigned. Because this is an area 2D, we do need to configure it, right, with this collision shape 2D. So let's go ahead and add that. And give this a shape. And I'm going to use this, I guess I want to use this polygon shape right here, okay? Actually, you know what? If we're going to use a polygon, there's actually we might even, in fact, look, there's a warning right here. The collision shape 2D node has limited editing options for polygon-based shapes. Consider using collision polygon 2D node instead. Let's go ahead and do that. I forgot that this is a thing. Let's go ahead, Control A, and it's right there, collision polygon 2D. Now, for this, we need to, why am I getting warnings? Okay. I don't know. That's probably something to do with adding and deleting. But let's go ahead and edit this collision polygon 2D. It obviously has no collision because it's empty. So let's go ahead and under this polygon, this packed vector 2, let's just give it 3 points. And what we can do is we want this cone. I'm going to make a cone. So it is going to be a vision cone. The first one can be 0, 0, which means it'll start at the center of this. And then let's say we want the enemy to see a certain distance out. We can set that as the X on both of these other points. And so this could be something like 100. Okay, and you can see that goes out 100 pixels. Really, it probably needs to be bigger. I'm going to go with a 256, which is quite large. I'm going to set that on both of these. And then what I'm going to do for the Y is on one of them, I'll make it a negative number, and the other one, I'll make it positive. And I want them to be the same number. So I'm going to go with 128. Okay, so you can see that move that one up 128 pixels, and this one will go down a positive 128. And that is now his vision cone. We can, of course, move this and adjust it. I'm going to drag it up so that the vision cone is centered like so. Okay, but that's our vision cone right there. Okay, this polygon. I don't know if you guys are going to love typing these numbers in, but for a triangle, pretty simple. If you're making some sort of complex polygon, then this might be a pain in the butt, but it is what it is. Okay. Now, another way to configure this, if you don't like that, is you can kind of come in here and, you can kind of just draw. But I don't like this because it's not very precise, right? So I do like typing those values in. I'm going to go ahead and just type this in again. So let's see, this was 256. This allows me to know exactly what's going on, if that's important to you. Okay, there we go. Back to normal. And just go ahead and reset this so that it's kind of at the center. Now you could move the collision shape, or you could move the sensor, actually. That would work too, which kind of makes sense. You can see it's centered there on the enemy. Okay, there we go. Now, because this player sensor extends area 2D, we've got all of these configuration options, but we're not going to set any of these in here. Even the collision, we're not going to set. We're going to set that through code so that it behaves precisely the way we want it to. And so we'll just kind of leave those alone and call that good. So now we've configured our slime with one of these sensors, and we're ready to hook it up and start testing the code. Before we hook that up, let's go ahead and just turn on our visible collision shapes. And we'll run this scene and just see what this looks like. Okay, so there's one issue that you'll notice right away, and that's that the vision cone is not changing direction with the enemy, but at least it's there. We can see that it's, part of the scene, right? Okay, so we'll handle that. That'll be one of the things we deal with as we get started here. So let's just come back to our script and open up this player sensor, all right? Now, the first thing that we can do in our ready function is we can configure the collision. And I'm going to start by disabling the collision on layer 1, which is that default mask that's set. So let's go ahead and do set collision layer value. Actually, we don't want collision layer. We want collision mask. Set collision mask value. Same thing as collision layer almost. Let's go ahead and open this up so that it's obvious though. So looking at our collision, we've got layers and we've got masks. Now you could also set the layer, remove that. It's not going to make too much of a difference though, because this is an area. But you know what? Let's go ahead and set both just to be safe. So we're going to set our mask. What we're going to do is actually just set 1 to false. Oops. So let's go ahead and just clear this. We'll do that to the layer as well. Okay, so when it runs, both of these will be disabled. And then we're only going to enable a mask for the player if this player sensor is part of an enemy that can take advantage of it. Otherwise, we can just kind of leave it alone. So what we'll do is we'll wrap this in a condition. And what we're going to use is we're going to check our owner. So if owner is enemy. Okay, and we've used owner before, but just as a quick refresher, it checks the node at the root of the scene that this is a part of, and it checks that's what owner is. And so we're checking if that is an enemy. Okay. If it is, then there's a couple things we can do. Before we set these collision layers, we know we can now assign our enemy, right? Because we know we have a valid enemy there. So we can say enemy equals owner. And then from here on out, anytime we need to reference the enemy, we can use that instead of owner. So let's go ahead and set our collision mask then. There we go, collision mask value. And what we want to set is the layer 5, because that's where our player is. Now, if yours is different, then obviously set the appropriate layer. But see here, mask for layer 5 is my player layer. So I'm going to set layer 5 to true. So now this area is going to be detecting for collisions with anything on that layer, which I've only assigned my player. And I'm going to go ahead and hook up a couple other things. We want to obviously hook up to this area 2Ds on body entered and on body exited. So we'll go body entered dot connect, and we'll call this on body entered, of course. Copy and paste this, and then just make another one for exited. Okay. And let's go ahead and create these functions. So I'm going to copy on body entered, make that function. Now this, if you recall, when we hook up to this, it does pass in the node. So we can do something like that. And then I'm going to copy this and create the on body exited based on it. Just like that. Oops, only one E. Exited. Okay. There we go. We've got our little listener set up. And let's come back up here. There's one other thing we can do in our ready function. And this is going to handle that issue where the vision cone wasn't flipping direction. Our enemy does have a direction changed signal. So let's just go ahead and connect to that as well. So enemy dot direction changed. Oops. Dot connect. There we go. On direction changed. And we'll make this as well. Now, we know that this on direction changed emits the direction. If we look at this signal on the enemy, right, it's going to have the direction, new dir. Okay. So we can go back in here to our player sensor. This is a float. And then we can hook up code down here. And let's actually go ahead and do the on direction changed right now. We can just set this up. It'll be ready to go. So we'll just say if new direction is less than 0, then we can scale our x on this. So scale.x equals -1. We also need an elif. Okay. Oh, I call this new dir. Oops. It's just dir. Then we can say elif. We don't want to handle 0. So if the direction changes to 0, that means the enemy probably just stopped moving. We don't need to do anything. Elif dir is greater than 0. Then we can set the scale back to 1. And we're only changing the x scale. Okay. So there we go. There's our direction changed. Now, just with these changes, hooking this up and this direction changed, we should be able to see that that's happening in game. Yeah, there we go. So as the slime moves left and right, the vision cone updates appropriately. Okay. Good. Make sure that yours does that, and then we're ready to move on. Okay, now let's go ahead and work on these body entered and body exited signals when we've connected to them. I mean, there's some obvious things we could do here, right? So on body entered, we could go ahead, we could assume this is the player because the way our collision is set up. And so I'm going to do that. If for some reason you needed to, you could check, you could say if n is player. Okay, that's valid. But I'm not going to do that because I know that he's the only one. And it might be bad to make assumptions, but whatever. I'm going to do it anyways. But what I'm going to do, there's a couple things. Let's go ahead and do a signal. So we've got our player entered signal, so we can emit that. So player entered dot emit. And then what we need to do is we need to grab our enemy dot blackboard dot target and set that equal to n. Okay. So now our blackboard's going to have a value assigned here. So rather than the target being null, which means there's no player, now it will have just a direct reference to the player, right? That means that your states and your decision engine can leverage that information and do whatever they need to with it. Blackboard doesn't care what we do with it. Neither does the player sensor. It's just there. Okay, so there we go. That's all our body entered needs to do. On top of that, we could come down here, our on body exited. We're not actually going to handle the node unless, again, you want to check if it was the player. Okay, then you could do that if n is player. There's two ways we could handle this, and we're going to start with the simple implementation that doesn't include the search just yet. And so we'll just say, is it player exited dot emit? And then we can grab our enemy dot blackboard and let's see, target equals null. Okay, we can just clear that target. Okay, now this kind of should work, but it's hard to debug this, right, without any way to listen to it. So for debugging purposes, and you can follow along with this if you want, it's really only necessary for now as we build this, but this is a general way that I tend to help debug stuff while I'm working. I'm just going to add a label like so, and then I'm going to just attach a script to this, and I'm going to go ahead and make it built in, because once I delete this label, I don't need the script. So I'm going to check that built-in option and say create. Okay, so what is this label going to do? Let's go ahead and let's grab a reference to, we could grab this player sensor if we want to, or I think actually what's going to be a little bit better is let's grab a copy of our enemy. Okay, and this way we can go ahead and kind of update the label to show what's on the blackboard. Okay, so I'm going to say text equals blank. Each frame we're going to clear this, and maybe we want to do this on the physics process, partly because it happens less frequently and also because that's when we're making our changes happen, so there's no need to check it more frequently than that. But now we can just say something like text equals, and then what do we want to do? We want to check if we have target equals Yeah, we could do comma. No, I think we should do plus. Well, what does it do if we do comma? Comma, enemy dot blackboard. Oh, it's not enemy, it's slime2. Target. Okay. Yeah, I don't think comma is going to work on there. It would if it was like a console. Oh, this is not, this is a, we could go dot name. That should work. Okay. Because that wasn't a string. It's expecting a string. So the name of this is a string. And then we can go like this. We can say text plus equals. And then what I want to do maybe is we can do a /n. That'll give us a new line. And then we can check something else if we wanted to. Actually, that's fine for now. Let's go ahead and just comment that out. Let's see if this works. So we've got this little script in here. I'm going to run it. Yeah, well, that doesn't work because we don't have one. Okay, that's fine. That's fine. That's fine. We're going to do this as a new line. We're going to say text plus equals. And then we'll say target name if slime2 dot blackboard dot target else just blank. Okay, that should work. Is that going to work? Okay, there we go. Target equals. Now, if I jump in here, there we go. It sees the player. It doesn't see the player. You see that? See how that's working? So pretty straightforward. This script might have been confusing. I wrote that real quick, but I hope that makes sense. So we're just setting this each time. We're updating the string, the text on here. And this is just shorthand for saying use the name if we have a target, otherwise use this string. You could do it in a regular if-else branch if you want to, and that sometimes is easier to read. This is just quicker, less space. Okay, so we know that this is working. Okay, now the other thing I wanted to do, maybe I was gonna display the distance to target. We don't actually have that yet, but let's just plug it in. So we'll make a new line, and then we'll say distance. I'm just going to abbreviate it, and then we can say text plus equals. We're going to grab our slime dot blackboard dot, what is it? Distance to target. Okay. This needs to be a string. This is a float. We can't add that. What is it? What is the str? There we go. Okay, we'll convert that to a string using this. Str will convert whatever's inside to a string if it's a compatible value, which many things are. Works with any kind of number at least. Okay, so if I save this, yeah, it's already updated. You can see our distance is -1, but we're not changing the distance. That's the default value we set it at. But hey, we know that our slime is kind of working, right? I mean, this not our slime, I should say, our player sensor is working because we see the player, we don't see the player. Okay, now what this will help us do is it'll help us determine if our timer for the search is working, and then we'll also be able to debug the distance that we're going to calculate. Okay, this sloppy code is throwaway. You're not going to want to keep this, but right, we're just using it for debugging purposes right now. So let's go back to our player sensor, and let's now implement the ability to detect if we're still searching for the player or to not forget about him instantly, okay? So we've got player entered, exited, started searching. Really what we should do is when the player exits, then if we're going to use this, then we should probably say started searching, oops, dot emit, okay? And then this stuff, I think, is going to have to happen later, right? Because what's happening is instead of just emitting the signal and removing a reference to the player, we're going to have to assume that we still see the player or that we're trying to get to him. And then what we're going to use is our timer, right, that we're created up here. And we're going to assign a value based on our search duration and just keep that reference in place until we no longer see the player anymore. Okay, so let's go ahead and do this. This code right here is okay, but we're going to have to move it. Okay, so I'm just going to comment it out. And then instead of calling that, what we'll do is we'll set our timer. So we're going to say timer equals search duration. Okay, timer. Okay, now this code, we can cut this, and we're going to use our physics process to help calculate all this stuff. Okay, so what we'll do here is we're going to say timer minus equals delta, right? We're just going to decrease the timer because down here we set it. And now anytime it needs to, we can decrease it here. And actually I'm going to do something a little bit different. I'm going to wrap this. I'm going to say if timer is greater than 0, Then we'll decrease the timer. And then here we'll say if timer is less than or equal to 0, then that means that our timer was above 0, but we just counted down, it just timed out. And then we can say, we can actually paste this code right here. Okay, so I'm going to paste that and uncomment it. Okay, so we're just going to have a simple timer. It will, if it's greater than 0, it will decrease. And then once it reaches 0 or lower, we'll emit our player exited signal. And now we can clear the blackboard target. So what should happen is we should have a 2-second period where the enemy still thinks he sees the player maybe, right? Okay, it says player. There we go. 1 alligator, 2 alligator, clear. Okay, so that's how that works. So now you can build that in. You can adjust that export variable so that it's short. If you have a really dumb enemy, you could set it to 0. And now he'll just like follow the player. But if you run out of his view or something, then he won't just like instantly forget. He might keep trying to chase. And then if you need a more advanced behavior, you could maybe build a state that relies on that. And, you could do things like have a searching value in the blackboard so that you know that it's not a normal chase state. Maybe it's a searching state. Okay, well, there we go. That's the basics for that. So the last thing that we have to do to make this player sensor fully useful is update the distance. Okay, now, actually, this player sensor is done. I don't think we need to touch anything else in here, okay? But where we're going to handle that updating script is from our enemy. So we have a blackboard. We actually created an update distance to target function or method. And you can see that if we have a target, then we calculate it. Otherwise, we set it to -1. So we can treat -1 as meaning we don't, that's like an invalid value, but it's something because we can't assign null to a float. So we'll use -1 for that purpose. But this distance will always return a positive number, okay? So we can count on it being positive if we have a target. We just need a way to call this, really. And obviously, this is expecting us to pass in a position. Now, this position, as you can see, is the position of our enemy because we're calculating our distance to the target, which is our player. Okay, so it makes sense then that we just take this function and we call it from our enemy. We weren't really implementing this before because it didn't make sense. We never had a target assigned. So now that we have it, let's go into our slime or this enemy script on our slime. And then we're going to go to our physics process in here. And we're simply going to call this right here. So we'll just say blackboard dot, let's see, update distance to target. And then we'll just pass in our own position. So we need to get our global position is what we want. Okay. There we go. So now what this should do, let's go ahead and run it. We don't have a target, so the distance is -1. But as soon as we do, you can see that the enemy is calculating how far am I from the player. Okay. And you can see that it is always a positive number. The way that distance works is just positive, right? It's just general. So now we've got information if we needed to know, like, okay, well, once I'm 40 pixels away from the player, I know I'm close enough to try and attack. We could code that into our decision engine or into one of our states even, and we've got all that information, okay? And of course, once we forget about the player, the distance is always -1, so he won't even try an attack. So there we have it. That's really all we need to make this player sensor. And obviously, there are other types of sensors you could make. I think a good homework assignment, one was to implement that search if you want to, right? Implement that search state, which is just maybe an extra Boolean in your blackboard that you can utilize. Now, the other thing is I would like you to try and experiment with different kinds of sensors that you might want in your game. So this basic one probably provides the things that you need for a lot of games, but maybe you want something like a stealth game. How would you handle being able to hear the player, right? Because you don't want to actually cue into real audio and try and analyze waveforms and stuff like that. I think that gets a little bit too hard, in my opinion, or too processor intensive. So could you fake it maybe? Maybe if they're within a large area or just a certain distance, you could even just calculate a sensor that just checks the distance between itself and the player. And then anytime the player makes a sound, it emits a signal that these sensors can hook into. You use that global message bus and it would say like player sound and include a position or something. And then this sensor could say, oh, am I close enough for my enemy to detect that sound? Something like that. Build some kind of sensor. There's probably some other good ideas that you guys have for sensors that you want. And it really depends on the gameplay that you're going for, right? So give that some thought, create some sensors, comment below what you're implementing, how you're going to use it in your game. And if you run into problems or questions, then drop those in the comments as well, and maybe we can address them in a future video. So thank you for watching. In an upcoming video, we're going to be making some modular and easy to use systems for particles, and we'll even be doing things like enemy drops and other things along those lines. Okay, so stay tuned for that. It's going to make it really easy to add and extend the functionality of our enemies, and we're going to continue to make it modular like this. And then we're also going to be starting to build new decision engine types. So we'll do a few examples of a few different kinds of enemies, some of them based on the enemies that were submitted to the design showcase, which that video just launched earlier this week. So you can check that out, which will be linked. And yeah, if you have any questions or comments, go ahead and drop them below. If you're new, please subscribe. Your interaction helps my channel grow. It tells YouTube if it's valuable or not. So I guess if it's not valuable, then don't subscribe. But otherwise, I appreciate it if you do. And as always, we'll see you next time.